highest common factor of the functions, HCF, or we can read it as a GCD. HCF is highest common factor, or we can read it as GCD also, greatest common divisor. Both are the same. So it's the greatest common divisor. So before seeing this HCF of the functions, let us see what is HCF and how to apply. Let's take the HCF for the numbers first. Okay, for example, 12 and 8. Okay, instead of discussing the functions directly, let us see HCF for 12 and 18. 12, 18. Highest common factor. First we should find out the factors for this. If you see factors for 12, it's 1, 2, 3. Because in 1, 12 is 12, 2, 6 is 12, 3. These are the factors. Again 4, right? 6. Next again 12. So these are the factors. 1, 2, 3, 4, 6, 12. Next similarly take the 18 factors. So 1 is common factor for all the numbers. Next to 2, 2 nines are 18. Next to 3 it is 3 table. Even 6 also. 6 also factor. 9, 18 itself. So these are the factors. In that next is the common. So common, if you notice, 1 is the common in the both places. 2 is the common. Next to 3 is the common. Next to 6 is the common. Right? In that highest one. So highest is the 6 only. Here and here. Therefore HCF of 12, 18 is 6. This we'll learn already some previous classes. So based on that, if you see the HCF for the functions, so directly let me take two functions which already written as the product of the expressions. For example, P of x, and one more function is a Q of x. P of x is, let's take x minus 5 whole square, x minus 4 whole to the power 4, x plus 2 whole cube, and Q of x. They already solved in the product of expressions. Now this is the P of x, one of the function. One more is Q of x. Let me take example x minus 5, x plus 2 square, and x minus 4. To find out the HCF for this, so if you notice, to find out the HCF, highest common factor, here we should not take the biggest number. P of x, x minus 5, x minus 4, x plus 2 are the factors, but x minus 5 is maximum is 2. But when Q of x, x minus 5 is only one time. Okay, in this common, if you take only x minus 5, but is only one time is the common. For this 2 times, x minus 5 into x minus 5, but it's only 1. So which is the small that you can take? So x minus 5, because x minus 5 here and here, there is x minus 5, here also x minus 5, but in that common part is x minus 5 to the power 1 only. Okay, this is power 2 means you can write x minus 5 into x minus 5, so 1 you can take. Next is x minus 4 whole to the power 4, x minus 4 only one time, power 1 it is, so 1 you can take, x minus 4. Next, x plus 2 is a factor for this, x minus 2 whole cube, and this x plus 2 whole cube and x plus 2 whole square. X plus 2 whole square is x plus 2 whole cube. X plus 2 whole cube means nothing but is x plus 2 whole square, and one more x plus 2 power 1 we can make. Okay, this we can treat as like this. So in that x plus 2 whole square is here, and x plus 2 whole square also is there. So x plus 2 whole square. So this is the HCF. So what we should notice here, from both comparing, which is the least we can take for this, is highest to common factor, but common, but in this which is the common, that part only should take. In that which is the highest, overall highest. Common should be, then only highest. Okay, this one. Let me give one more example. If P of x is equals to x square, y cube, and z, Q of x. xyz square. Okay. For this to find out HCF. So here is x square and x two times is only one time. X is a factor, but is this only maximum is 1 only. This is 2, but we can take only x to the power 1. And next y cube and y. So y 3 times, but is only y 1 time. So we'll take only 1 y, so which is least. Here is z to the power 1, z to the power 2. So you can take only z. That's it. So HCF of this two functions is only single term, so monomial. Then the HCF is x into y into z. Okay. If they'll give the factors already, this is the way we can do it. Instead of giving the factors directly, they'll give some expression. So let me see one question. For example, how to find out HCF of 10x to the power 4 minus 7x cube plus x square and 4x power 4 minus 2x cube minus 2x plus 1. So such type, this is the function. Now this example we'll see in the next topic. So previous I just explained when they'll give factors how to find out HCF. Next topic we'll see even how to find out some examples, how to find HCF when they'll give the functions.